it's actually, one could say, a new kid on the block, because he just appeared at the end of last year in the public with an eVTOL. I heard about this before, and when I heard it, they were already nearly flying with a real full-size prototype, which you see there in the back. So Michael Kügelgen. Michael, give us a view. Wait, let me go and grab you the PPT forwarder so that you can take your PPT and go through the PowerPoint. And I suppose this is just a starting flight, and then we can move on, and you can give us a view what is the state now, how you did get there, and what is the future we can expect from you.
Again, my name is Michael Kügelgen. I'm a mechanical engineer, but I'm also a pilot for many decades. And within the next 8 minutes, I would like to give you a short introduction who we are. I would like to explain the technology, and we will see by the end of the day the video of the flight. And as I said, I'm the founder of eMagic, and I'm responsible for the aerodynamic design, and I'm also the test pilot. And I'm flying for 45 years fixed wings, and also for the last 15 years helicopters. This is also one of our partners. Such a project is only possible if you have strong partners. This is Matthias Schrieker from Dornier Aircraft. He was responsible for the mold milling and for all the composite work. This is Professor Florian Holzapfel. He's a professor from the University in Munich, and he's responsible for all the flight dynamic and control systems. This is the brother of Matthias Schrieker, Thomas Schrieker. He made all the load analysis and dimension of the aircraft. Helix and Richard Krüger, he made the propeller design for the forward engine and for the lifting engine. And last but not least, this is Moritz Pletschinger. He did all the software of this aircraft. When we started, we had several design targets. This first, it should be a really proof of concept. So this is the reason we made a single-seater. And it should be fully electric. It should take off and land vertically with an endurance of up to 1 hour, and with a top speed of almost 100 knots. And to reach this goal, we had to fight for the lowest possible weight, and we had to make our own power plants. And of course, the aircraft should be as very low noise level. Our strategy was to have a parallel development, to first develop only the aircraft, and to independently from that develop the copter system. We defined milestones, and we have very intensive tests. Here you can see the mold making. Left is the winglet mold, this is the main fuselage mold. We did all the composite work. And we not only did this aircraft out of carbon honeycomb structure, but also the main struts with a high tension model fiber, which has a strength 2.5 point stronger than the conventional carbon fiber. So we have been able to make a very strong, very stiff, and very light airframe. You see every. So what we developed was the complete airframe, as I said, the power plants, including the electric, including the controller, the battery and the battery management system, and the propellers. And the next step, everybody is asking, okay, it's a beautiful aircraft and it's flying very nicely, but it's only a single-seater, so the next step for sure are now the multi-seater with a twin engine. And based on the eMagic 1 concept, we also have a drone which can lift up to 100 kg. And now I would like to show you at least how eMagic 1 is actually flying.
Yeah, and like I just discovered, or we saw in the morning, we have some problems sometimes playing the videos directly out of the PowerPoint. That's why we're going to start the video separately. It will come in a second, and you can later, if you want to see the video again, if you want to show it to some friends, which is here on the show, they have the books, like said, at the back. And there you may have a look at the video. It's permanently running there on the screen.
And not only as a video, the aircraft is also standing there. It's a black aircraft in the dark room, so it's almost invisible.
It's stealth, so it's the first. Okay, so video can start right now. Thank you, Michael, and impressive, and especially when you see the time frame in which he developed this with his little team. And we hope that perhaps next year we'll see the real aircraft flying here at AERO, because we are at an airfield, so it's an ideal opportunity. Now I come to our next speaker, Mark Henning from AutoFlight Europe. Mark is in the aviation already a long time, but with AutoFlight I think you're not that long, just from the beginning of this year. But AutoFlight has been with their AutoFlight X prototype in 2019, one of the stars of the show. Now it has progressed, so I hand the word to you, Mark.
First of all, I would like to congratulate you for your passion and energy to build such an aircraft with such a small team. So believe me, we have a little bit of understanding what it means to get something flying. Yeah, hello. Thank you very much for coming here and showing interest in our company. My name is Henning, Mark Robert Henning. I'm the managing director of AutoFlight. And as Willi said, we started quite early this year in January with a small team, and a small team has a certain task, a mission to be accomplished, which I'm going to talk about a little bit. Our aircraft and our company. The company is founded by my boss, Tian Yu. Tian Yu started many years ago, more than 20 years ago already, with electric flying. And his passion was always to develop electric flights for society. One of the breakthroughs, of course, was this capability to have a vertical takeoff and landing. And in 2011, he filed a patent for that, which is called lift and cruise. And as we see, many other companies are following that logic of lift and cruise, because we also think that's the way to go, as it is sufficiently simple as a product and can be thus developed, certified, and also operated. The company AutoFlight itself, as it is today, was established in the year 2017. We are located in 3 areas, a big team in Shanghai, China, then we as AutoFlight Europe in Augsburg, at the airport in Augsburg, and as we're speaking, we're building up AutoFlight US. Currently about 400 people, so it may be a little bit bigger than you are. The company started with products and on a small scale for lift and cruise. With this, what we call the White Shark, a 70-kilogram unmanned drone for cargo delivery, which grew also in 2019 for a first flight in the Albatros, about 100-kilogram payload, again vertical takeoff landing, fully electric. And you can see that the configuration, which was followed from the V50 to the V400, is also followed through to our current product, which we call Prosperity One. Prosperity One shall be an eVTOL of the enhanced category. That enhanced category shall transport up to 3 passengers for commercial operation, and it's going to fly with a pilot. So different than something which you're trying. We're doing the more conservative approach to have an aircraft with an actual pilot, as it shall be EASA certified. As we are speaking, we have 2 so-called proof of concept aircraft flying. This is the picture here of the proof of concept 1. And it is about 1,500 kilogram takeoff mass today. It shall fly up to 200 kilometer range at a speed of about 100 knots or 180 kilometers. The logic, maybe I can do that a little bit more short. The aircraft takes off in what we call the multi-copter mode. We have, as you have, 8 lifting propellers with 8 individual electrical motors to propel the aircraft in vertical flight, and then is going to be performs a transformation in what we call fixed wing flight. And with that fixed wing flight, currently we have, with the 1,500 kilogram aircraft, a very low power consumption need. When we fly our targeted cruise speed, we use up to 80 kilowatts only, which is quite good already in the proof of concept, which is not yet aerodynamically fully refined. The 2 aircraft which I just mentioned are flying currently, and what are they doing? As they are proof of concept, and we are investigating with these aircraft our basic aerodynamic models. We are validating our flight mechanical models. We are trying to validate our control laws for this. Of course, we measure in real full scale the loads which are applied on the aircraft, which are applied on the propulsion system, which are applied on the, especially, and you will find that also, on the lifting propellers in the transition phase. And of course, the power manager, and this is a full electric aircraft. Until end of this year, we shall utilize the tests of these proof of concept aircraft to freeze our configuration, to start the full-scale development for our real product, which shall be certified with EASA later this decade. As AutoFlight, we have to do a product, so Prosperity One shall be a serial product. And there's a lot of discussion within our company, but also within the industry, is how much are you going to do yourself and how much are you going to procure supply from the existing environment of aerospace. One of the challenges we have here is that the market forecast tells us that there are many thousands of aircraft needed every year, which have to be produced not only by AutoFlight but also by our competitors, of course. That brings special challenges for what we call the vertical integration. So the aircraft itself is going to be, of course, most lightweight, as it is a vertical takeoff and landing aircraft, you know that. So it's composite airframe. How much are we going to build ourselves? How much are we going to buy? For sure, as we're flying today, the integration of the flight control system together with the avionics system and all the, let's call it the software environment around that, is developed as we're speaking in our company and shall be controlled and managed by our company ourselves. The dependency on the in the serious production, especially on the main element, which is the propulsion system, the batteries, the electrical motors, and the management systems around that. We also think that it's going to be worthwhile to investigate, to develop and build these components ourselves in the serial production. And so this is going to be quite an interesting journey to go there. Mid of the year, we are intending to disclose a little bit more details on our proof of concept development and on the product development. So the pictures you're seeing here are not the final pictures of the aircraft. It is the proof of concept aircraft. So you have an indication here at the end what we think the final aircraft is going to look like for our four-seater aircraft. And with that, I thank you very much for the short time I could do my introduction. Did I keep the time?
Thank you. Yeah. Thanks for speaking so fast. That's the thing is, I always try to get a little bit more time here, but at Aero there are a lot of people who want to talk because the whole industry is here. So we have to keep ourselves short, and I always want to have some time for talking afterwards, for asking questions. So thank you, Mark. I continue to our next speaker, where we go now. We have Germany, we had a joint venture or a company from China, which is also active in Europe. Now we go to a part which has been part of the European Union not so long ago, but now UK is different. I think this is interesting because when we talk about the certification, now it's a CAA, which is responsible for you, not anymore directly EASA. So my next guest is Seyed Mohseni of the company Samad Aerospace. I've heard and seen images of your company already from, I think, 2018 was the first appearance I saw. Recently, I saw that you have a scaled prototype, 50%, I think, flying already. So I thought, now it's the time, we have to have them here. They're getting closer, getting airborne. So please.
Thank you. Thank you, Willi. Good morning, everybody. Good afternoon. I don't know, probably, yeah, good afternoon. It's a pleasure to be here. I'll briefly today, obviously the presentation is longer, and I guess this will be made available for everybody to have a look later on. But I would share with you our insight and experience during the last, I would say, 5 years of going through this development, and we are continuing at this exciting path. And for me, it's important that people, the audience, would benefit from what we have to say. From our point of view, there's some, realities into the market, and there are three main segments within the advanced air mobility sector: the intra-city, or in a way, urban air mobility part, pure urban, or intercity travel, or unmanned aircraft usage, whether it's for cargo or surveillance and various other activities. We think for intra-city travel using eVTOLs, this is probably a decade down the line. So it's not the low-hanging fruits because of significant certification challenges and regulatory aspects. The infrastructure that requires to get this moving, but also the financial part of it, which needs to be addressed. Which I guess this is what you can see that initially.
No, micro is away.
You can hear me. Oh, okay, it's good. Yeah. Okay. There were some, very, exciting conferences run by Uber during the last few years, and now you can see that these excitements are dwindling, and some realities are coming, and some logic are coming to the discussions. We think intercity travel is the low-hanging fruit, using existing infrastructure, and there are already existing markets that the companies could address in comparison to existing helicopters and general aviation aircraft. And some of the technologies that have been developed so far could be used for the unmanned side as well. As I mentioned, the infrastructure is already in development and initiation at the moment, but there's significant work needs to go into it. The social aspect, obviously, for people to be able to accept this type of flying vehicles, whether from noise pollution or visual pollution, and whether these type of technologies would be available for masses, that's another question. On the technology side, I would say the contenders, they are developing quite well, and there are certain aspects related to technicalities of developing this type of aircraft, which I will share with you in a minute. There's some key, very, very key areas that would affect almost the entire design of the aircraft. So on the technical side, I would say designing an aircraft that is certifiable to be able to achieve the target is the key technical problem. Because how you solve a problem is one thing, how you solve it so that you can certify it is another one. As an example, you have heard some battery developers, they come and they say, okay, we can achieve energy density of 500 watt-hour per kilogram, but then when you put that into the context of developing the aircraft, you would see the same battery probably can achieve around 150 watts at best. So there's some other challenges related to the certification, because we have VTOL as the initial initiation that was suggested by EASA, and similar approaches to in FAA. The single most important aspect that the developers they need to know, and also the investors they need to know as well. When we talk about the failure cases of 10 to the -9, that means this type of aircraft needs to be developed at the same safety level as large airliners. And then when you put that into the context of how long it's going to take for large airliners to be developed and how much does it cost, so the numbers are in billions rather than hundreds of millions. So people need to appreciate that level of commitment in terms of the financials, unless that the aircraft can be developed under CS27, Part 27 type certification, which then the case would be slightly different from failure case point of view. I guess you all are familiar with the benefits of time saving that all of the eVTOLs will provide, because they overcome the need for the runway and so on. So during the last few years, we developed various, probably over 12 different prototypes of various sizes. This is the latest one, the half-scale prototype, which was a technology demonstrator for the E-Starling, and that is the 5-seater aircraft. There is a combining of the lift cruise, but also tilting mechanism for the highest speed and helping to the transition. Hybrid electric, we believe that it's going to take some time for battery technology to get to be able to provide reasonable range for this type of aircraft. The key problem related to the disk loading. Now, the higher is the disk loading, the higher is the power consumption. And the higher is the power consumption, then the more battery we require, the heavier the aircraft will become, also larger electric motors we require. We should not underestimate the cost and time required to certify an electric motor. We ourselves, I'll put my hands up, we were guilty of thinking that we could use existing off-the-shelf electric motors to start with, and then after a couple of years looking into the details, we realized that certifying an electric motor is almost as difficult as certifying gas turbine, and also cost. We are in communication with a few of the companies who are certifying electric motors, and significant levels, over $100 million type for 150 kilowatt electric motors. Now, the other thing is, this is not just a technical problem, it's the key problem related to the intercity travel or regional air mobility was very well defined in the report that was done by NASA last year, similar time last year. The key problem is, for this market to unlock is the cost. Bottom line is the cost to the end user. And having an eVTOL aircraft that would do 4 or 5 seats would not achieve the cost that the market would require. So we need to move towards a concept that can achieve 9 seats. This is the current focus of Seyed Aerospace now. How can we achieve on the CS-27, R-27, 7,000 pound aircraft, how can we achieve 1 pilot and 9 seats? Because that would deliver the cost that the market would require. Now, the numbers that people are putting out, that these aircraft cost similar level to the electric car, I don't know where they bring these numbers from. They are hugely underestimating the cost of the operation, which is probably would be known during the next few years. So for us, the focus is moving into the operation, trying to understand the intricacies of the operation of this type of aircraft. What are the underlying costs that we are not appreciating as developers? And we have some very, very good brains behind it to be able to help us where we are, and also very excited about the partners that we are working throughout the Europe. I guess there's a video about the test of which I sat in the aircraft on a helicopter type test, which was really fun. Also gave a lot of confidence to our engineering team. Somebody else was flying the aircraft, right?
Yes, thank you for being so quick, and sorry again for rushing you, but we're going to show the video, and the thing is, we will have the PowerPoints also available later. Not all, but those PowerPoints which we received that we can distribute them. You will see them on our website, and so you can get more information. Also the links to the manufacturer's website, where you mainly find much more information, but we could spend all day talking about this probably with each of you. So sorry for rushing you. Video is ready, so let's go.
Bewegen, das sich ein bisschen denken können. Schon so konzeptionell, ne? Also sieht schon ein bisschen klein aus. Ob Sinn macht, weiß ich nicht. Weil
Thank you very much, and I hope you enjoyed it. And like I said, we will have links to the companies, to the videos, so that you can more detail look at this later. Michael disappeared. Okay, but he's still already having the Q&As, which we will have later. But I hope he'll come back to our stage. Anyway, we continue. Announcement of this panel was European and old players, new kids on the block. So Tom is neither European nor is his company, but we know us for a very long time in aviation, in all different times, coming from hang gliding, ultralight, and he has a very huge knowledge in certification. At some point, I think you also worked for FAA in the United States. So what I would like to have him first a view of his company, Wisk AERO, which is a company which is in the VTOL business already quite a while, through different names and different vehicles, and they are very active also in the groups which are around in Europe, in United States, and in other places of the world. So Tom, give us a view of your aircraft and about the regulation which you think should be there, are there for the certification, and especially the point on your vehicle, you don't want to leave the pilot out from the beginning, as I understand.
Thank you, Willi. Very happy to be here. So Wisk is a company that has been around a while. We are looking at this market from a global standpoint, so very happy to be here to talk about what's happening in Europe as well. But first, let me give you a little background on the company. So when we look at why we're developing the product and the service we are, here's a great number to look at. Global average time lost due to congestion, 210 hours. We have to move to the sky. So why now? Technology is advanced and can meet commuter demand for alternative mobility options. Transforming urban commutes is not an overnight process. There are many factors that require consideration, planning, and development. However, cities that partner with UAM leaders now will see long-term benefits tomorrow. So our vision, less time getting there means more time being there. Our mission is to deliver safe, everyday flight for everyone. So who's Wisk? We have about 385 employees, mostly in engineering, manufacturing, and flight test. Somebody asked me earlier today how many employees we had, and I said, I don't know until I see this slide, because it changes every day. We're growing very quickly. We're headquartered in the San Francisco Bay Area, where our headquarters is. We also have operations in New Zealand and Atlanta. We have more than 1,500 test flights conducted, and these are all full-scale aircraft. And we're backed by leaders in aviation, the Boeing Company and Kitty Hawk. So it's an interesting combination in this joint venture. Wisk is funded both by Kitty Hawk, that is a Silicon Valley startup, where there's where you would expect there to be a lot of innovation, but we're also partnered with Boeing, with over 100 years of history in the development and production of aircraft. So it's a very good fit from that standpoint, and we're able to access a lot of what Boeing can bring with all of its tradition. So if we talk about the product a little bit, let's meet Cora. So it's self-flying, therefore no pilot on board, all electric, eVTOL, 2-passenger, powered by 12 independent lift fans and 1 pusher prop. So you can see in the image the fans along the wing, and the pusher is a little hard to see in this picture, but hopefully we'll do a video later for you to see better. Operates 1,500 to 500 feet above the ground. Think helicopter-like. Oh, did we lose the image? No, it's back. Roughly 100 miles per hour, 25-mile range, plus reserves, no single point of failure, ground control monitoring, and more. It's important when we use the term autonomy or autonomous flight that in our operational picture, there will always be a human involved one way or another. So in our case, we still will have people on the ground who are involved. So this product is designed for urban air mobility, and it's built for safety. We've been at this a while. I've been with the company about 8 years, but we've actually had 10 years worth of flight testing. We've been through a number of iterations, learning as we go along. So you can see here we have a number of generations. What Cora is Gen 5. There's more coming. Look forward to sharing that when we can. So our concept compared to most is a little different, as Willi mentioned, where we're self-flying first. So we will not start with a pilot in the cockpit and then slowly migrate the pilot out, as many others are. We're going right to the end state. We think this improves safety, and it's where AEM is ultimately headed anyway. Definitely easier to scale. No issue with the pilot shortage. It's lower cost. It's simpler to maintain. We have a few focus areas, especially because of our concept of operations at the federal level. We're a US-based company. We're focused right now in the US, but we also want to make sure that we're looking at this from a global standpoint. Therefore, being here and talking with EASA, for instance, is important to us. So if we look at these areas, which are universal AEM integration and coordination, the industry and authority cooperation and collaboration. We are working with NASA in their national campaign and participating there with autonomy, collaboration, and path to certification. That is a unique aspect, and that we're looking at now instead of later, and incorporation of autonomy-based operations. So our whole picture, given that we're going to start with autonomous aircraft, is a bit different than most, and for us, we're putting a lot of effort into that now. With airspace integration, to define the crawl, walk, and run stages for autonomous operations. You can imagine, and I think we might discuss this a little bit later, that from a regulatory standpoint, they're not ready, and probably won't be ready for some time. And therefore, you hear a lot about the expectation of starting with a pilot on board. That's one approach. That's not the only approach. We're taking a different one. And since we won't have a pilot on board, then our plan going forward will not necessarily start the very first flight over a city with passengers with no pilot on board. There's going to be steps along the way. So as part of that, in New Zealand, we are participating in an aerospace integration trials program, which is focused in on autonomous operations, and it's the ability for these aircraft to interoperate with our conventional system that is in place today. New Zealand's special because they have a little different regulatory scope that allows for things that we can't do in the US or in Europe right now. So it's very exciting for us to be able to participate in that. Advancement of FAA and NASA ConOps. This is something that while we have our own plans going forward, it's really important that the industry gets behind central focus of what the path forward looks like, and to make sure that that's consistent with regulators. And then on the infrastructure side, you hear about discussions with developing vertiports or places to land with these kinds of aircraft. If you have a pilot on board, you can treat it kind of like a helicopter on the vertical component. But if you don't have a pilot on board, then the systems that are going to be required, both on the aircraft and on the ground, are going to be a little different. So that's something that is important for us. And then we want to leverage and operate into existing infrastructure. So the expectation is not massive changes at the beginning. So use what's already there. We're just going to have to enhance it. A little bit like when we talk about electric propulsion, the need for charging, regardless of whether you have a pilot on board or not. That's one of those things that's universal. We've put together some white papers to share with the industry some of these thoughts and get people's ideas. So you can go to our website and download these. And there's a lot of information there. We've thought about this for a long time, and now we're starting to share this so that we can first share our vision, but also get some feedback. So when we start to look more at the global picture and how that might affect the ability to offer this service to the aircraft on a global scale, Wisk is very proactive, participating in industry groups, standards development organizations, and other groups to try to promote working out common solutions that are universal, that can work in a number of different jurisdictions. Jurisdictions, though, have their own laws and their own regulations, and they don't always match up. So in some cases, you can't have harmonization one for one, but you can often have mutual recognition or validation, and that is, if that could be minimized, that's going to be very helpful for the industry to be able to move forward at a reasonable pace. So as a goal, harmonization or validation is something that we are promoting wherever possible, and participation in that groups is one of the ways that we can share what we're doing and help promote that. And then the safe operations are going to prosper if we have appropriate regulation. It's been said that this being new, likely the regulators are going to be very conservative, and often it's talked about having an equivalent or higher level of safety than we do today for the airlines. So if you understand the burden of creating a new Airbus or a Boeing, for a startup company to be able to match that is asking a lot, but a lot of this has to do with public perception of safety. So it's going to be a high bar, and that's something that is really important to keep in mind when trying to get to the end goal of actually having a product and a service that's available.
Tom, because we're leaving a little bit time for the discussion.
I'm happy to jump right to either the video or to stop.
So if you just finish up, and then I think we skip the video because there are some questions here. And you go to the Wisk Aero, just the website, perhaps you have it.
Wisk.aero.
Wisk.aero,
Yeah.
and sorry again for this, but
No problem.
I have to rush. So we have a Sin, can you perhaps help and take the microphone? So if anybody of you has a question, we have a mic here, so ask the question, because now we have still about 10 minutes left for questions, which I think is always very important to have some communication in the scene. And so for me, I start with a question which came up. So my first, so just lift your hand when you have a question, and then, so you can start right away, even in front of me. I will fill the
Thanks so much. Hi Tom, my name is Katrina, we met before. I'm actually joining AutoFlight soon. And my question is, since you work with the FAA and now you're working on the other side of the game, you mentioned all these challenges and hurdles to get to certification. Looking from the side of FAA and your experience, what do you think is the right way to get there? How do we get EASA and FAA to actually get the certification?
So what has been said over and over again is that there needs to be engagement, and what the authorities would prefer is that you follow the normal process. So apply first, and then you can start that dialogue for your specific project. Because everyone is different. Right now we have it's a little bit like the Wild West. There are so many different platforms, methods of finding solutions for things and they're all new in many cases. So that for those areas where there are gaps in the regulatory requirements or in the means of compliance, that the best way to approach that is just one-on-one. In the meantime, as I mentioned, to be able to pull the industry together and have the discussions about those things where you can find commonality. The regulators definitely appreciate when the industry comes forward with agreement to say, we think this is a good approach, because they really don't want to have to do this 400 times in a row, everyone a little bit different. The amount of time and effort to do that really slows down the process. So from the industry standpoint, it's in our best interest to work together wherever possible.
Okay, thank you, Tom. I have a question on Seyed, on your aircraft, because how would be the energy supply for your aircraft? Because you're talking about 9-seater, you're talking about a smaller vehicle in the beginning. So what are your steps? Are you looking for a hybrid vehicle? Maybe it's because we were cutting you so short that I didn't get the right point. So please, you can...
Yeah, thank you. The prototypes that we have built so far, they're all electric, because they were linked to the technology demonstration, but also integration and aerodynamics of the whole systems. But certainly our approach is hybrid. We think that's the more reliable approach, where we could use sustainable aviation fuel and possibly hydrogen as well as a contender to battery.
Okay, thank you. I have another question. As we are here at the Aero Fair, and at the Aero Fair we have a lot of ultralight. It's actually one of the, I think, the fair in the world where you have most of the ultralight. And Michael, you said in your presentation, and we see the aircraft there, which is flying as ultralight. So is this just like some others have done for being getting easier testing, and then later you also jump to the larger one, or you want to continue until you have a real flying aircraft as ultralight?
Yes, at the beginning we were looking in all different directions concerning the certifications, UV and DERC, and finally we found the right partner with Dulf. We had a quite strong and good documentation, because we started right from the beginning in parallel with the building. So it was quite easy to get this preliminary permission for flight. And this is how we would like to continue. And the single-seater is definitely not an aircraft to sell it in hundreds or thousands of these units. And we would like to continue with this on this ultralight track, no question.
Okay, thank you.
there is a question from the...
Thank you very much for your presentations. I'm Anders Schreifer from Turbulence Solutions. We want to make flights turbulence free, and now a question on certification regarding bad weather operation. So it's not just about getting into the air and having some scenic flight, fair weather operation, but you want to have IFR operation in turbulence flight and so on. So do you consider turbulence? Is turbulence an issue? What about comfort aspects? What is the aspects regarding certification in bad weather operation?
I think if we are already running short, maybe Mark, you could answer this question first, and then we get the answer from the others too, because I think it's a question for everybody. So then we can go through, and then probably our time is off.
And that's mean to give the question to me. Huh? So the easiest thing against turbulence is high wing loading, huh? Which comes, of course, with cost. That you have to fly faster. This is something, traditional light aircraft, all of them have to fight with turbulences, of course, and we are no different because when we're talking about the cruise flight, when you operate as an aircraft, which is true for all of us here, we will have to deal the same way with it as the others. So take down your CL alpha, so what is CL alpha, and bring up the wing loading, and then half of it is done. I don't think that we yet have internally talked about actively control our control surfaces to interpret that there's a gust coming and to actively control, to elevate the gust loads by active control. The good thing is that all of our aircraft have the full authority flight control system, so implicitly you could think about doing that. So I give you something now.
Thank you. Yeah, so if you go with that approach of having a software as a control system, then you're talking about over $1 billion certification cost for this type of size of aircraft. And that's why a lot of developers, historically, they always try to avoid certifying a software. A simpler approach could be for the smaller aircraft is to not certify the aircraft for those conditions, and that will obviously significantly limit the market. So I would say for the VTOL aircraft, there has to be significant level of speed difference between the propulsor speed and the wind speed, which then that would increase the gap between the turbulence weather and the aerodynamics of the propulsion, which in that case would make the operation safer.
I'm not sure I can add much. There are different phases of flight. So we have our vertical component, where you probably are going to run into certain kinds of turbulence just because you're close to the ground. Once you're up and flying on the wing, that's a whole different set of things to consider. But if you consider that just from a design standpoint, if you're creating something that doesn't, for which you have a wing that doesn't need to have the same stall characteristics because you're not depending on the wing solely for your takeoff and landing, you can have a very high loaded wing right from the get-go, just as part of the design. So you might have some things just built in. The other, which was just mentioned, for which there's a cost factor, is that if you have a completely digital aircraft to start with, you may be able to build in some systems there to more actively approach that. But otherwise, we already have a lot of requirements to meet that are already baked into the certification process. And then we have to keep our customers happy. So there's going to be all those things to consider and making decisions based on that. I'm sure that if you don't have a product that is comfortable to ride in, people won't ride in it. So that you just need to factor all that in.
Okay, thank you. I think we are nearly up with the time, but I just heard that the next presenter is not here yet, so that's why we may continue with one or the other question. I have one, which I would have for Michael, because he was mentioning with one slide there that you're also working on a drone version, and I've seen AutoFlight has a drone version of the aircraft. I think Samad is also planning drone version. Do you think the drone market will come first, or do you think the urban air taxi market will be first?
As you know, 35 years back, we were developing the first drones, and we've learned that we have been too early with that. And today there is a big need and demand for this unmanned air vehicles, and we got already more requests for these drones than for the single-seater. So definitely we will focus also on this derivate.
Okay, thanks. Mark, perhaps same question, we just go through the question, and then I think we are done for today.
Yeah, so we in AutoFlight, we have the same interpretation. There's a big demand for drones, and the drones are going to be there more early. Of course, in less regulated airspaces than we have in EASA, to be honest to say it like that. It's easier somewhere else. But on top, the market predictions on the air taxi, on the eVTOL to transport people, is assessed to be much bigger than for cargo operations.
Okay.
Yeah, we also believe the same. That's why the half-scale prototype of the E-Sterling is about 600 kilogram maximum take-home weight with a capability of 100 kilogram payload. And that seems to be a good attraction from the market for cargo delivery.
Okay, and Tom, is Wisk also working, or is somebody of the other companies working with you, working on unmanned drones as well? Because your vehicles are unpiloted but manned. You also working on unmanned vehicles?
We're putting all our focus into passenger carrying. So yeah, we'll leave it to the rest here to take care of the cargo market.
Okay, thank you very much. And with this, I have to close here. Again, I want to make a little bit advertising for it's a guide which the Aero Fair has put out here, because we see there is so much going on electric, especially when you come only for one day. It's very difficult to keep up. So follow us, follow this in the web. You will also have the reports of all the new stuff which came out here during the show, and then see you somewhere at the next show. We also have some eFlight Forum which will be online only, so if you keep tuned, you get all the latest information. Thanks very much for joining, and thank you to my presenters here.